Now let us see the next problem type, which is based on riverman problem. So let us see a question. A person is swimming with a speed of 10 meters per second at an angle of 120 degrees with the flow and reaches to a point directly opposite on the other side of the river. The speed of the flow is x meters per second and the value of x to the nearest integer. Okay, let me draw the situation. So we have given a river and the river is flowing in the right direction with a speed of x, right? And there is a person who is swimming at an angle of 120 degree with the flow. So this is the velocity of the person with respect to the river, right? And it reaches to a point directly opposite on the other bank. So it means the velocity of the person in ground frame will be along this line. So that will be Vp in ground frame, and this will be Vr. This is the velocity of the river in ground frame. So the resultant of Vpr and Vr will be nothing but Vp. And this angle is given as 120 degrees. So it means this angle will be 30 degrees. Now we have a right angle triangle where this angle is 30. This is x, and velocity of the person with respect to the river is given as 10. So that is 10 meters per second.
So before I start solving this, if you're preparing for JEE or NEET and you feel stuck with concepts, strategy, revision planning, or question solving approaches, then you can check out Pracbee. At Pracbee, students can book personalized one-to-one mentorship sessions with experienced mentors to get individual guidance based on their own strengths and weaknesses. Now with that said, let's get into the question and see the smartest way to solve it.
Now we can apply trigonometry, and so sine 30 degrees will be x divided by hypotenuse, which is 10. So x comes out to be 5 meters per second. So that is the answer, right? Now let's see next question. A swimmer can swim with a velocity of 12 kilometers per hour in still water. So that is the velocity of the swimmer with respect to river, 12 kilometers per hour. Water flowing in river has a velocity 6 kilometers per hour. The direction with respect to the direction of the flow of the river water he should swim in order to reach the point on the other bank just opposite to its starting point. It is similar to the last question. So this is the bank. These are the banks, and this will be the velocity of the swimmer with respect to river, and this angle is theta, and this is velocity of the river, which is given as 6, and that will be the velocity of the swimmer, and it is given as 12. So this angle is alpha, let us say. So sine alpha will be 6 by 12, that will be 1 by 2. So alpha is 30 degrees. So theta will be 90 plus 30. So that will be 120 degrees. So 120 is the answer of this question. Now let's see this question. A swimmer wants to cross a river from point A to point B. Line AB makes an angle of 30 degree with the flow of river. Magnitude of the velocity of the swimmer is same as that of the river. So here we have given velocity of swimmer with respect to river same as velocity of river. Let me take it as u. The angle theta with the line AB should be so that the swimmer reaches the point B. Okay, right. So let me redraw the diagram. These are the two banks, and let us say this is the velocity of swimmer with respect to river, and that is the velocity of river, and this is the velocity of swimmer in ground frame. So this point is A, this point is B, and this angle is given as 30 degrees, and this angle is theta, which we have to calculate. This is u, and this is also u. And since VSR is same as VR, we can say this angle is also theta, right? And if you look at this angle theta, it is alternate angle, right? So theta and 30 are alternate angles. So theta is nothing but 30 degrees. So the answer will be 30 degrees. Now let us see the next problem type, which is based on like Rainman problem. A girl standing on road holds umbrella at 45 degree with the vertical to keep the rain away. So he's keeping the umbrella at an angle of 45 degree. So it means the rain is falling in this particular direction where the velocity of the rain makes an angle of 45 degree with the vertical. If she starts running without umbrella with a speed of 15 root 2 kilometers per hour, the rain drop hits her head vertically. Okay, so velocity of rain with respect to the girl is in the vertically downward direction, and this is nothing but velocity of rain minus of velocity of girl in ground frame. So if this is the velocity of rain in ground frame, and this is the velocity of rain with respect to girl, so it means the girl velocity should be in the left direction, so that minus Vg is in the right direction. Only in that case we will get Vrg in the vertically downward direction, because Vrg is the resultant of these two vectors, right? Vr and minus Vg vector. So what we have given, a velocity of rain is not given, but this angle is given 45 degree. So this is 45, this has to be, so this is 45, this is 90, so this is also 45. So this is also 45, right? So Vg is given, right? So Vg is 15 root 2 in magnitude, and we have to find the speed of the raindrop with respect to the moving girl. So Vrg we have to calculate. So in this right angle triangle, this is 45, this is 45, this is 15 root 2. So this has to be 15 root 2, right? So 15 root 2 can also be written as 30 by root 2. So option C is the right answer.